Voyager 1 did not send coordinates to a hidden planet. It sent measurements from a place where empty space stopped behaving like nothing. No photograph. No glowing object. No mysterious structure caught on camera. Just a position in space, magnetic field readings, plasma waves, and a faint signal traveling more than 15 billion miles back to Earth. Hidden inside those numbers was something far more interesting. Evidence of an environment beyond the Sun's protective bubble, where interstellar space leaves measurable fingerprints on a spacecraft. That is the real mystery. Not what object Voyager found, but what Voyager reached that could only be understood by crossing the edge of the heliosphere. Voyager 1 crossed the heliopause in 2012 and entered interstellar space. Its mission was never designed to hunt for alien objects. It was designed to study the environment beyond the Sun's influence, including magnetic fields, particles, and plasma waves. And its plasma wave measurements revealed something remarkable. The space around Voyager was not perfectly empty. It contained plasma, magnetic fields, density variations, and waves. To human eyes, interstellar space looks like a black void. To Voyager's instruments, it has texture. Voyager 1 stopped taking photographs decades ago. After its famous 1990 family portrait of the solar system, its cameras were turned off to conserve power and resources for the interstellar mission. So when Voyager sends back a position alongside a strange measurement, that location does not point towards something it photographed. It tells scientists where a physical change was detected. A plasma wave. A magnetic field variation. A change in density. A disturbance moving through the thin material between stars. That changes the meaning of the coordinates. They are not a treasure map. They are more like pins placed inside an invisible ocean. Here, the plasma changed. Here, the density could be measured. Here, the magnetic environment behaved differently. Voyager is not looking at interstellar space from a safe distance. It is traveling through it. That distinction matters. Telescopes can observe distant stars and galaxies by collecting their light. Voyager is doing something completely different. It is directly sampling the environment outside the Sun's heliosphere. The heliosphere is an enormous region created by the solar wind and the Sun's magnetic field. It pushes outward into the surrounding interstellar medium, while the material between stars pushes back. The boundary between these environments is not a solid wall. It is a dynamic region shaped by pressure, particles, magnetic fields, and disturbances from the Sun. Voyager crossed that boundary. And by doing so, it gave humanity measurements from the other side. But there is a major limitation. One spacecraft cannot map an entire environment. Voyager 1 is following a single path through an enormous region of space. Every measurement tells scientists what happened at Voyager's location, but one point cannot reveal the complete structure of the surrounding medium. A single reading could be a local disturbance. A temporary density change. A pressure front. A wave moving through plasma. Or part of something much larger. That is why repeated measurements are so important. A single coordinate is a clue. A series of measurements becomes a trail. And a trail can reveal patterns. Voyager 1's plasma wave instrument has allowed scientists to study variations in the density of interstellar plasma over long periods and distances. Instead of one strange event, researchers can examine how the environment changes as Voyager continues moving farther from the Sun. That gives scientists something incredibly valuable, a direct sampling of the local interstellar medium. And this is where the story becomes more fascinating than the idea of a mysterious object. The unknown may not have a surface. It may not have an edge. It may not even be a single thing. It could be a pattern in the medium itself, a region where plasma density changes, magnetic fields shift, or waves move through the interstellar environment. To a camera, there may be nothing to see. To Voyager, there can be something to measure. And that is why the phrase, unknown object, can be misleading. Voyager did not discover a secret planet. It did not find an alien spacecraft. It did not detect evidence of extraterrestrial intelligence. It discovered something more fundamental. Interstellar space itself is a physical environment. It contains thin gas, charged particles, magnetic fields, dust, pressure, and waves. The space between stars is not nothing. It only looks like nothing from far away. Voyager has now spent years traveling through this environment, and its remaining instruments are becoming increasingly precious. The spacecraft was launched in 1977. Its power source has been slowly weakening for decades, forcing engineers to shut down instruments and systems in order to keep the mission alive. Today, Voyager 1 has only a small number of scientific capabilities remaining, including its magnetometer and plasma wave subsystem. One measures magnetic fields. The other detects plasma waves. That is an extraordinary situation for a spacecraft built nearly half a century ago. It is still traveling through interstellar space with only a fraction of the capabilities it once possessed, while engineers on Earth carefully decide which systems can be sacrificed to preserve the remaining science. Every measurement therefore carries more weight. If Voyager encounters a new density structure, the plasma wave instrument may be able to detect it. If the magnetic environment changes, the magnetometer may record it. If another disturbance passes through the surrounding plasma, Voyager may capture the signature. But eventually, the spacecraft will no longer have enough power to keep all of those scientific senses alive. Voyager will continue moving even after the science stops. The spacecraft will drift onward. But Earth will no longer receive the same detailed information about what surrounds it. That is what makes these measurements so valuable. Voyager is not showing us a picture of the unknown. It is allowing the unknown to interact with the spacecraft and then sending the evidence home. A vibration. A magnetic field measurement. A density estimate. A coordinate. A tiny piece of information from a region no human can physically visit. And perhaps the most important realization is that the mystery is not located somewhere far ahead of Voyager. It surrounds Voyager. The spacecraft is already inside the environment we are trying to understand. The coordinates are not pointing toward a hidden body. They are marking places where the invisible became measurable. And that gives us a completely different way of thinking about the edge of the solar system. From Earth, the heliosphere is something we mostly have to model. From Voyager's position, it becomes something that can be sampled from the outside. The Sun is no longer the entire environment. The galaxy is pushing against it. Interstellar plasma surrounds it. Magnetic fields connect the region to the larger galactic environment. Solar disturbances travel outward and interact with material beyond the heliosphere. The boundary is not static. It is a dynamic interface between the Sun and the galaxy. Voyager is giving us tiny pieces of that interface. But there is another fascinating clue. Voyager detected plasma waves. These are not sound waves traveling through empty space. Space is still a vacuum, and ordinary sound cannot travel through it the way it does through air. Instead, plasma waves are oscillations involving charged particles and electromagnetic forces in the thin plasma surrounding the spacecraft. To Voyager, they become electrical signals. To scientists, they become measurements of the environment. And those measurements can reveal the density of the interstellar plasma around the spacecraft. That is why the hum detected by Voyager should not be interpreted as a mysterious voice from deep space. It is physics. Charged particles moving through an extremely thin medium. The interstellar environment responding to disturbances. A supposedly empty region revealing that it has structure. That is the real wonder. Interstellar space is not a perfectly smooth ocean. It can fluctuate. It can carry waves. It can change density. It contains magnetic structure. And it interacts with the heliosphere surrounding our solar system. Voyager is sampling that environment directly. The spacecraft is essentially placing tiny markers into an invisible ocean and reporting what the water is doing.